too many people. So when you're calculating oxidation numbers and ions, we know that the oxidation of every atom every atom in the ion needs to add up to the total charge of the ion. So can someone tell me what the total charge, the overall charge of this is? -2. Do we all agree on that? Do we all see that, right? It's up here in the upper right, it's -2. So all the oxidation numbers of all the atoms in this ion must add up to -2, okay? We know we have 2 carbon atoms, and it's asking for the oxidation number of that. So we're gonna put that as X, okay? So 2X, that's what we're looking for. We need to add to that. We have how many oxygens? 4 oxygens. And what is oxygen's oxidation number in 99% of compounds? -2. The only exceptions are peroxide anion, which you have 2 oxygens, which each one has a -1 charge to give it an overall -2 charge. And when oxygen is bonded to fluorine, so FOF2, in this case, oxygen would have a +2 charge. Those are the only 2 exceptions for oxygen, okay? So at this point, if you can get here, it's just algebra, right? So you're gonna get 2x minus 8 equals -2. Take this over here, 2x equals 6, x equals 3. And that's the oxidation number for each carbon. So it's x is equal to +3. Does that make sense? How I arrived at that? Okay. Any questions? Questions? Okay. Balancing chemical equations. Is this something y'all went over in basic chemistry? Yeah. Okay. So everyone, how many people got this one right? Okay. So this is just really manipulating things, right? For combustion reactions, is like a combustion reaction is like a hydrocarbon. So C carbons and hydrogen reacting with oxygen gas form carbon dioxide and water. Not all the time, but a lot of the times you end up having to put a 2 in front of the first thing. So in front of the hydrocarbon. So I always just start with the 2 here. And then I start getting the carbons next. So we need 12 carbons on the right side, because we have 12 carbons on the left side. We need 20 carbons or 20 hydrogens on the right side. So we put a 10 here. And then now we have 24 oxygens here. We have 10 oxygens here. That's 34, which means you need 17 here. So is that the correct answer? That's the right answer that y'all got in class. Okay. So again, it's not every balanced chemical equation that I put a 2 up front. It's just these combustion reactions where I usually notice, I guess so much practice, I've seen that a lot of the times it has 2 over here just because of the odd number of oxygens over here. And you end up having to like multiply this by 2. So I start with this, then figure out everything else. And then the last thing I should do is the oxygen by itself, because that's the easiest one to balance. Okay, any questions on how I balance that? No questions. What about, wait, did you unmute on Zoom? Okay. Any questions on Zoom? No questions. Okay. Number 17. What volume of silver in milliliters has a mass of 75.44 pounds? Density of silver is this. Okay. So the first thing I noticed, what's the first thing y'all notice when you look at these units? Okay, I'm going to answer John's question first. So John said, is there a specific element or order you start with? And like I said, if it's a combustion reaction, if you learned about combustion, I'm not sure, did y'all learn about types of reactions? And okay, so if you learned about that, and if you took basic chem, you should have learned about combustion reactions. in a bunch of reactions, you have this field, and I always end up just putting a 2 in front. 90% of the time, it needs to be there in order to properly balance. 10% of the times, it can just balance without the 2. But again, that's not all the time. And I'll save the O2 for last, just because it's the easiest thing to balance, because everything else has 2 elements in it, whereas this just has 1, so it's easy to balance the one that has only 1 element. But for other types of reactions, it's just trial and error, I guess. Okay, what volume of silver has a mass of 75.44 pounds? What's the first thing y'all notice when y'all look at this? Look at our units. Density is in grams per milliliter. We're given pounds. What are we thinking? Speak louder.
Convert pounds to grams.
Exactly. And how would you do that?
What is it at 454 grams?
Maybe.
Pretty sure that's what we said yesterday.
I usually just go to kilograms. So we know there's 1 pound. What is it? No, it's 1 kilogram is equal to 2.205 pounds. And then I want to go to grams, just because that's the only conversion factor I know. If you know the other one, good. But if not, then you're left with memorizing the other one that I'm telling you. Okay. And we know 1 kilogram has 1,000 grams. Pounds cancel, kilograms cancel. Now we have grams, and we can incorporate our density into this equation as well. So we know the density of silver is 10.5 grams per milliliter. So 10.5 grams for 1 milliliter of silver. And grams cancel, and we're left with volume in milliliters. And you put that in a calculator, what do y'all get? Got it. Anyone have an answer? I got an answer, but I'll let y'all. Or we know how to use our calculators before it's time. We have to memorize the English to SI units. Yes, you need to memorize those units, not each one. So you don't need to know how many inches are in a mile, but you may need to know how many, well, that's actually English to English. You may not need to know how many grams are in a pound. You could, it'll help you. But I know kilograms to pounds, liters to gallons, and inches to centimeters, and that'll help you solve all the problems you need to solve for this class, because you got length, mass, and volume. Yeah. So did anyone get an answer on this one? Can't hear you. 3,000. Okay. Thank you. 3,258.390. All right. How many sig figs? 4. So what is this round? 3,258. Do we agree on that? How many of y'all are still unsure on how to solve that problem? Again, it's really just manipulating your units. If you write your units and you know that you have to cancel out your units, then to get to the correct unit, then that's really, it won't be that difficult. This practice. How many of y'all didn't know how to do 18? Raise your hand high with pride. Okay, thank you. So that helps me. So a net ionic equation for the following reactants. everything that is aqueous, what does aqueous mean? It's dissolved in water, right? If it's dissolved in water, is it a solid or is it in its ions? So does salt, sodium chloride, when you put it in water, does it stay as sodium chloride or does it break into sodium ions and chloride ions? What?
Stays as sodium chloride.
No, it breaks into its ions, which is why we're able to conduct like electricity through water that has electrolytes in it, because those ions are able to carry the electric current. So if it's aqueous, that means it's dissolved in water. If it's dissolved in water, that means it's been ionized. If it's ionized, they broke apart, okay? Do we understand that idea? So everything that says aqueous is able to be broken in water, which means on the net ionic equation, it's going to cancel out if it's on both sides of the equation, because if you're aqueous, if your ions on this side and your ions on this side, what we call that is a spectator ion because it didn't participate in any reactions. But if your ions on this side and you're solid on this side, clearly some sort of chemical reaction occurred for that to happen. So let's look at this. Copper and nitrate, copper 2+ and nitrate. It's aqueous, which means that this broke up into copper 2+ cations and nitrate anions. Are we good there on how we broke that? Because it's aqueous. What about, can we break this one up? Why? It's aqueous, right? So it's dissolved in water. So we have K+, we have 2 K+, and we have carbonate. What about this next one? Copper 2 carbonate. Can you move it to the right? Copper 2 carbonate. Can we break that one into its ions? And why? It's a solid, right? It's not aqueous. So therefore we can't break it. It's not broken into ions. So we keep it as that. What about the last one? Potassium nitrate. So it's aqueous, which means we have 2 K+ and 2 NO3 minus. We all see how we determine which ones we can break and which ones we can't break. If any questions, say it now before I keep going forward, or else you're just going to get more confused if you are already confused.
Speak now or forever hold your peace.
No questions? I'm going to continue going forward. So now everything that's an ion on the left side and on an ion on the right side is what we call a spectator ion. It doesn't participate in the reaction. So you can cross them out, okay? So what's an ion on both sides here? Shout it loud because I can't hear it. Potassium, right? So we can cross that out. What else? Anything else? Nitrate. Therefore, the things that participated in a reaction were copper 2+, carbonate, and it produced copper 2 carbonate, solid, okay? Or that should be in our net ionic equation, okay? So by process of elimination, and if you got this part, then you should be able to just figure out what the last one is. So anything with K, just cross it out. Anything with nitrate, cross it out. So K, nitrate, that one looks good. Nitrate, K, nitrate, K, C. How many of you are still confused on that? You just got here, right?
By chance, have you gone over number 14?
Yeah, we went over those yesterday. It's on our YouTube channel if you want to check that out later.
I'm not even sure if it is on the YouTube channel. I'll post that right now.
Okay. He'll post it right now, actually. But yes, so we went over everything from 1 to 14 we went over yesterday, and Rich is going to post that on our YouTube channel. I sent a link to that yesterday in the room, so check that out.
Okay. Thank you.
Here we go. So there's no questions on number 18 because you're definitely going to see something like this on your test. Again, if you understand the basic concepts of what you can break into ions and what you cannot break into ions, then you should be able to solve this question pretty easily. All right, yeah.
Would there be a scenario where one of the compounds that we're putting into net ionic is a gas?
Are you able to speak up a little? I heard, is there ever going to be a scenario where something?
Where it's a gas instead of like an aqueous?
Oh, so usually this is happening in solution, so you won't have gases in solution, but if it is a gas, you can't break that into its ions. So that would be in the similar column as a liquid or a solid. Does that make sense? That's a good question. But usually like ionic compounds won't be found in their gaseous phase just because you need extreme temperature to get to that. So the most you'll see in these types of problems is solid and aqueous, okay? That was a good question. Any other questions? So any state of matter is not broken apart. Only aqueous, exactly, yeah. Okay.
The whole aqueous thing means dissolved in water, so.
Perfect. If there's no questions, I'll go to number 19. Number 19 is a freebie if you just know basic dimensional analysis. Start with what we're given. So 650 feet per second. It says it wants in kilometers per hour, but it gives us a conversion factor from miles to kilometers. So what we need to do first is get to miles. So we know that there's 5,280 feet in 1 mile. Now we can use the conversion factor. So 1 mile is equal to 1.607 kilometers. And does that give us our desired unit on the numerator? Yes, right? Feet cancel, miles cancel, and we're left with kilometers. Now we need hours on the denominator. So seconds, we need to cancel that out. So we know that there's 60 seconds in 1 minute. So that goes away. And we know that there is 60 minutes in 1 hour. That goes away. We're left with our desired units of kilometers per hour. And putting this into your fancy calculator, 650 divided by 5.0. Anyone else get an answer yet? If say it loud so we can.
712.19.
712.19. Yeah. And how many sig figs are we going to care about here?
3.
All right. I got 2 answers. I got 2 sig figs and 3 sig figs.
Oh, 2.
2. The person that said 3 sig figs, do you understand why it's 2 now?
Yes.
So yeah. Here, if there was a decimal here, it would be 3, but because there's not a decimal, we only take the first 2. So it's going to be 710. So the answer you get in the calculator is 712.19, but we're going to take this to 710 when we take into consideration our sig figs, and you get kilometers per hour. Okay, does that make sense?
Real quick, those of you who are concerned about the YouTube channel video, that's been uploaded, but it's still processing, so give it like another hour or 2 before you can view it.
Yep. What is the name of? That was about to say. What is the name of that?
Copper 1 sulfide.
Copper what? Copper what?
Sulfide.
How do you know it's copper 1?
This sulfide, which is SO3, has a charge of -2. And since there are two copper ions or two coppers, each one has to have a charge of only +1 in order to make it neutral.
So just reverse crisscross.
That's true. There was another question.
The question was, can we write 710 as 7.1 times 10 to the 2? And traditionally you can, or you will be able to do that. They are the same thing.
Yeah.
So, yeah.
Yeah, they're both the same. 7.1 times 10 to the 2 is 710. You'll get credit for either one you put, okay? Yep. So what this guy or this gentleman said, I don't know your name. What's your name? Robbie. Okay, what Robbie said was he did the reverse crisscross thing. You can't do the reverse crisscross thing with the 3 here. Why? Because that's part of the polyatomic ion. So what we have to realize is that there's actually only one sulfite here. I know this, again, this just requires memorization, but you need to know that SO3 is sulfite, and the 3 is how many oxygens there are. It's not because of the charge, okay? So, but on the other hand, this one here, this 2 can come up here. This 1 can come over here. So you have Cu plus 1, CO3, 2 minus. Okay, that tells us we have a +1 charge on copper, and then we need to know this polyatomic ion name. That's just memorization. What is it? If you have the right answer, please feel free to say it.
Sulfite.
Sulfite, right? Again, that's just memorization. If that's what you're struggling with, just do some flashcards. Maybe no. So with sulfite, we can cross out everything that's not sulfite. So let's see. Sulfate, sulfate, sulfate. Okay. So now we know we have it down to 3 answer choices. We know copper can have multiple charges, so we have to obviously clarify which charge that is, and to do that with Roman numerals. So B is wrong, because it's a charge. And we said from doing the reverse crisscross that copper has a +1 charge, so it must be C. Copper 1 sulfite. Any questions on that? Okay, no questions. Last one. How do I know when to reverse crisscross? Is when it's asking for like a name and you're given the ionic formula or the formula of ionic compound. So for example, let's see. No, that's a bad one. Okay. So this one here, what is the name of this? So the way I know to reverse crisscross it is because I need to figure out the charge on iron, because iron can have a charge of, it can have multiple charges. So let's take the 3 up here, and then we'll bring the 2 up here. So we get Fe2 plus and PO4 3 minus. What is the name or what charge is iron? So 2. So it's going to be iron 2. And then what is that polyatomic ion? Yeah, phosphate, right? So P. Any questions? Does that make sense on how we did that? Ionic equals metal plus non-metal. Perfect. All right, last one. Which of these is a oh my gosh, I can't speak right now. Which of the following is a physical change? Or yeah. So what we're going to do to see which of y'all have a misunderstanding is, I'm just gonna say, raise your hand if you think this is a physical change, and we'll just go through them, okay? So if you think grilling a steak is a physical change, raise your hand. Don't wait for someone else to raise your hand, or don't go with your crowd. If you in your gut, you feel like, I think grilling a steak is a physical change, but you don't see anyone else raising your hand, raise your hand so I can explain. Or I'll just move on. You're right. Okay. So physical change is something that you can reverse. So like solid ice going to gas, water vapor. You can eventually take that back from water vapor to solid, right? But if you grill a steak, say someone says, I want my steak medium rare, but you cook it to well done. Can you say, take this to the chef and tell him to uncook it backwards, or I don't know. No, because it's undergone so many chemical changes in there that you can't reverse the process. So that's how you know it's a chemical change and not a physical change. If you can reverse the process, it's a physical change. Okay, so grilling a steak would be a chemical change because you can't undo a cook. You can't take a cooked steak and turn it back into a raw steak. Okay, so that's chemical. What about burning propane? No.
Chemical.
It's chemical, right? Because if you're burning propane, you're undergoing some sort of reaction. It's going to produce carbon dioxide with water. Okay. B is not it. Condensation of ethanol. Okay. We got a couple people raising their hands. I see a lot of people over here not raising their hands. Why not? Y'all don't think it is? Talk to me, guys. It's a physical change. Okay. So you clear your head. Thanks. So that is a physical change. Let's keep going. What about electrolysis of water? If you don't know what electrolysis means, then you may think, oh, maybe that is a physical change, but it's not. Electrolysis of water is breaking water up into ions. So like turning H2O into H plus and O2 minus. It's a chemical change because you no longer have H2O, you have ions. So D is wrong. Clearly, C is the correct answer. Condensation is going from what state of matter to what? Gas to liquid, right? Perfect. Any questions on this before we move on to the next one? There's no questions.
And the whole thing.
No.
For number 12, yeah. Do you like the formula? I just need a formula to go.
There's not a formula for that.
Like you could say something like number of atoms times mole over. Just look at your units, and then like the way I did it, just look at your units and then make sure your units cancel out at the end. That's the best thing you can do to check. Like see how there's S atoms, and then I said for 5 S atoms at the bottom, and then 5 S atoms at the top, but it all cancels out. Like molecules cancel, then moles on top, moles on bottom, those cancel, left with grams. Your only answer.
It's really just playing with your units, like see what units match up and then make them cancel out so you can get to your desired unit, okay? That's all dimensional analysis is. So if there's no questions on this paper, I'm going to go to the next one. Yeah. Go ahead.
Can you walk through 14 again?
14.
Yeah.
Okay, so this one was a long problem. How about we save this for after, because I spent like 5 minutes on this problem yesterday and I explained it like twice on the YouTube video. And I want to go over something that I haven't done yet, just for more practice. And because it's on YouTube, you can check that out at any time today, okay? So if we have time, I'll go over it at the end, okay? but I'm not trying to be mean or anything. I just want to go over stuff that we haven't looked at yet, okay? So let's see. What's the next thing? Take some of this stuff really quick.
Are there physical copies?
No, we don't have physical copies, but are you in the group meet?
Yes. Is it that 11 page?
It's the version 2 or something, like V2. I just sent it like right before the session.
You like work better with physical copy?
I'll just go home and print it out.
Yeah.
There's a printer like downstairs too.
Sometimes we'll post like 80-page exam reviews. Please, for the love of God, do not print those out.
Watch it.
Yeah, try not to print those out, please. So share my screen here. So I want to cater to what y'all feel like you need. If y'all are perfectly fine with conversions like these, I'm not going to waste your time on that. Okay. If there's only like one person that raises their hand for this, I'm not going to waste my, I don't want to be rude, but I'm not going to waste my time on it if there's 20 other people struggling with a specific one topic, okay?
You can just like shout out topics y'all are struggling with. Like, what's one thing you absolutely don't want to see on today's exam?
Is it like question 14?
Number 12.
Okay. We can do a similar problem like that. Okay. Let's see. I got some. It was sent in the group me if you're in there. I sent it like about 30 minutes ago or so. Okay. So do y'all see this number 3? This is solution type stuff. This is using molarity. What do y'all think about this one?
Let's go over it.
Okay. We'll do this one first. What is the molarity of a solution when 482 grams of magnesium chloride is dissolved in 3,583 milliliters of water? Assume the volume of the solution doesn't change when it's added. Okay. So what is our very special equation that we use for molarity? It's moles over liters. I see someone, Myra, put grams per liter. Make sure it's moles per, yeah I'm sure that was a simple mistake. Okay, so the equation we're using is moles per liter is equal to. Do we have liters? Do we have the volume? We can, right? We need it in liters, but we're giving that in milliliters. So 3,000, there's 1,000 milliliters in liters, so that this translates to 3.583. So we got that. So we only need one more thing. It's the moles, right? I'm trying to take this step by step so y'all can realize that it's really not that difficult. If you know the equation and you know what you need to solve for that equation, then it's really just a matter of doing the calculations to get there. So now we need moles. Do we have moles of magnesium chloride? Well, I always think if we have the grams of magnesium chloride, then we automatically have the moles of magnesium chloride. So yes, we do have it. It's just given it to us in a different unit. So let's change it from grams to moles. How do we do that again? All our mass. So what is the formula? This requires you to know what magnesium chloride is. What is the formula for magnesium chloride?
MgCl3.
Mg has a 2+ charge, Cl has minus charge, -1 charge. So you combine that to get MgCl2, just like he said. Molar mass of magnesium chloride, can someone tell me what that is? 95.205. Is that right? I think that's right.
Yeah, that's about right.
Okay. So we just got that from the periodic table. Now we just need to put this into a calculator. 5.063 moles of MgCl2 is what we would get. Now we have everything we need. Molarity equals the moles, which is 5. So moles over liters, which is equal to 5.063 moles for 3,000 or 3.583 liters. This should give you about 1.41 molar magnesium chloride. How, on a scale from 1 to 10, was that a 10 in difficulty, or was that, what do y'all think it was? What do y'all feel? Just shout it out, guys. Yes.
1. That's like dense.
Right? This is probably one of the, like, in comparison to question 14, y'all better be praying you get this question on your test instead, okay? Yeah. So this is not that bad of a problem. They do become more complex than this. So easy only because not a lot of conversions, exactly. Now, if they give you like 4 cups of water and you need to get that to liters, no questions on this? No? Okay. This one's a very easy one again, relative to question 14. How many of y'all think you know how to solve this one after reading it? Okay, I with pride. Okay, try it. Y'all try. If you're struggling, if you don't think so, if you don't think you can solve this, maybe try it, and then I have the answer key here. So at the end, maybe you can come up to me. Hey, is this right? And if it's not, I'll show you what you did wrong. But I'm going to move on to questions like question 14 with the limiting reactant. Perfect. Okay. So what mass of, what is this here? What's the name of it? Potassium oxide. In grams is produced when 25 grams of potassium is reacted with 20 grams of calcium oxide via the chemical reaction below. So it gives you a chemical reaction. What do you notice about the chemical reaction that it gives you? It's not balanced, so we should balance it. So to balance this, all you need to do is put 2 there and everything works out. So these types of problems, every time you're given information about more than one reactant, what should be the first thing that comes to mind?
I mean, that's also something, but you talking about like more how you solve the problem.
You're given information, so like 25 grams of potassium and 20 grams of calcium oxide. Yes, just like Valeria said, you should be thinking about limiting reactants. Every time you're given information about more than one reactant, you should be thinking about limiting reactants. So to figure out how to solve this, all you need to do is find which product is it concerned with. Okay, so it's potassium oxide is the thing it's concerned with. That's just from reading the thing here. What mass of K2O is produced? So that's here. When these two substances are mixed. So that means we have to get from our reactants to grams or moles of potassium oxide. And then we can compare from there. So let's start with whatever one. Which one do you want me to start with? It doesn't matter.
Potassium.
Potassium, okay. So we have 25 grams of potassium. 25 grams of K. Or mass of potassium is 39.098 grams per 1 mole. And using our balanced chemical equation is how we're going to get from moles of one thing to the moles of another thing. So what's the ratio for this? 1 to 2. So for every 2 moles of potassium, 1 mole of K2O is produced. And if you put this in your calculator, you should get 0.3197 moles of K2O. How many of y'all are trying to write out all the stuff I'm writing as I'm doing the problem? Just because I'm only wondering, because when I watch people do problems for like organic class, I don't like take notes or anything. I watch what they're saying. I listen to what they're saying. I watch what they're doing. And then I try to solve the problem later on by myself. So if you're just copying everything I'm doing, you're not going to understand my thought process. Maybe you can try to like sit this problem out and just try to watch what I'm doing and listen to what I'm saying. And then you can go back later and try to solve it yourself. I can send you the key later so you can check it, make sure, but try to just listen to the process and listen to what I'm saying, watch what I'm doing, okay? And I'm not trying to be rude or anything. That's just how I feel I learn best. And I think maybe that could help y'all if y'all are struggling with, no matter how many times I see this, I can never do it by myself. Maybe that's because you just try to watch me do it. Or, yeah. Okay, I'm gonna stop ranting, okay? Anyways, that's moles of calcium oxide. The next thing I need to figure out is how many moles of calcium oxide is produced from the other reactant, which is calcium. You need to figure out how many moles of potassium oxide is produced from the other reactant, which is calcium oxide. So how many grams of, we had 20 grams of calcium oxide. All right, so 20 grams of CaO. The next thing we should do is what? What do you say? Molar mass to get what? Moles of calcium oxide, right? So exactly. So similar to the first step, we're just going to get moles of calcium oxide, so that way we can eventually transition our moles of one substance to moles of another substance. Okay. So we do that with our molar mass, which is 56.078 grams per 1 mole CaO. What do we do next? Molar ratio, right? And why do we do it? Of a different thing, right? We don't care about calcium oxide, we care about potassium oxide. Exactly, so Myra said to cancel out calcium oxide units. So this is a 1-to-1 ratio. So 1 mole of CaO produces 1 mole of potassium oxide. And when you put this into your calculator, you should get 0.3566 moles of K2O. So now we need to compare which one produced less. That's going to tell us which one was the limiting reactant, but it's not asking which one is the limiting reactant. It's just asking what should be the theoretical yield. So which one produced less? This is the one from potassium. This is the one from calcium oxide. We're looking for the one with the lower number here. So which one is it? Potassium, right? Thanks, Myra. So now what I do is just, I cross out the one that we don't want to use. So I don't end up using it on accident. So now we need to get 2 grams of potassium oxide, and we do that using what?
Molar mass.
Molar mass of it, right? So K2O is 94.196 grams. It should be about 30 grams after taking into consideration significant figures. Okay. Any questions on any of the steps? So yeah, this is your answer for number 8A. No questions? We're all good? Let me zoom, sorry. Yeah.
If there was 2 moles of K2O, would you also divide, like right there, then by 2 moles?
If it was like right here? If that was the case, but this is balanced, so you wouldn't. Like this is all balanced because you have 2 potassiums on each side.
Yeah, I'm just like,
But yeah,
okay, if there was a different
if it was a different reaction where you had 2 and 2, you would do the molar ratio would be 2 to 2. So it would just be 1 to 1, right? So it would cancel out anyways. But yes, you always go by what the ratios or the molar ratios are in the balanced chemical equation. Does that answer your question? Cool. Good question. Any other questions? No? Okay. Next one is part B of this problem. So the student successfully performs the experiment above and collects 23 grams of product, specifically potassium oxide, and now wants to know what the percent yield is. So what is our equation for, is this solving for limiting reactant? Yeah. So the first one we did was solving for limiting reactant. Well, it's not asking which one's the limiting reactant, but you have to solve for which one was the limiting reactant, so that way you can figure out what the theoretical yield was. And we figured that out to be potassium. Anyways, Palladius says it's actual over theoretical, which is true. So percent yield equals actual over theoretical times 100. So what was our actual yield? 23, right? That's what the student got in lab. So this is equal to 23. What was our theoretical? 30. It was from part A. So 30. 30 was our theoretical. That's what we solved for. And doing this, you should get 76% yield, which is actually pretty good for anyone. Actually, this is like you can publish a paper with 76%. Questions on that? No. We're all good. Was question 8 difficult? Okay. What did it be? 77? Is it 77?
I think 76.6 repeated.
76.6. We'll say it's 77. So I just went off the answer key that I had from about 3 semesters ago. 77. Okay. You want another problem like this? Okay. Whatever I see, yeah.
So if it is 76.6, you would round it?
We have 2 sig figs. Yeah, so someone asked, well, would you use 1 sig fig or 2 sig figs? Because this problem, like specifically part B, only gives you one number with 2 sig figs, you would use 2 sig figs. And so, yeah, if it's 76.6, you would round it to 77. Okay. Anyways, another problem like this, or yeah.
So this is like more just a general question. When you're like calculating sig figs, do you just kind of like not do anything while you're like calculating the numbers, but when you have your final answer, that's when you do the like sig fig?
Yeah, so normally like for part A, if part A is a question, like it is its own standalone question, it's just a sub question, I'll do sig figs for this, and then whatever answer I get here after sig figs, considering sig figs, I'll bring that over here. Okay, so in the calculator you might have got 30.1, but I'm not going to use 30.1 here. I'm going to use the answer that I put for this. Okay, just so that way you can say, well, this is the answer I got for part A. This is the answer. That's what I used for part B. Okay.
You're using sig figs from like the word problem, like that's where you're getting the like lowest number of digits or whatever.
Exactly. Yeah. So like you have 25 and 20. 20 has 1 sig fig. This has 2. So that's why I put 1 sig fig in the answer here. Yep. Okay. Does this one look difficult? That's something you want to go over? No. This is just using Avogadro's number to figure out, go to moles and then go to mass.
Will you be both extra?
Oh, okay.
Yes. So yeah, you can, I'm skipping some, but you can go ahead and try those on your own and you can check the answer key. Okay. Okay, so this one is asking which one's the limiting reactant, and then it asks for percent yield. Yeah. Actually, I think this one's better because this one gave it to you in moles. This one's actually a really easy problem that I gave it to you in moles, so I did most of the work for you. So I'm going to jump down to number 14. Okay, are we okay with that? You can check the other one later by yourself, and I'll send out the answer key. And all my work is on the answer key, so it doesn't just have the answer key answer; it has all the work for that. So we're going to do number 14. Has a lot of stuff. So it's asking. The first one is asking what is the oxidation number of copper in this thing here. So for ionic compounds, the oxidation number is just equal to the charge of the compound or of the ion. So to do a reverse crisscross thing, we do the 2 goes, 2 goes up here. This 1 goes here. So you get Cu plus 1 sulfur or sulfide. That. So it's asking for copper. What's the oxidation number of copper? Plus 1, right? So plus 1. Boom. Got answer for A already. Anyone need me to explain that one again? If 80 grams of copper is reacted with 25 grams of sulfur, how many grams of product can be produced? What is the limiting reactant? Let's see. What do we start with here again? Which one do you want to start with? It doesn't matter. Copper? Okay. So we take 80 grams of copper. What's the next step after this? What do we do? So molar mass of copper is 63.546 grams per 1 mole. Yeah. Oh, I forgot to do something up here. What did I forget to do? Balance, right? Next time someone yell at me if I forget to do that. So that should be the first thing we always do in these problems is balance our chemical equation. To do this, you just need to put a 2 there. Okay, so 1 mole of Cu. What's the next thing I should do here?
Molar ratio.
Okay, molar ratio. What is the ratio of product to reactant?
2 moles of copper for 1 mole of copper sulfide.
Yeah, copper 1 sulfide, right? So 1 mole of Cu2S gets 2 moles C copper. Okay. And before you go to grams, I usually just end off at moles so that way I can figure out which one's the limiting reactant first before going on to another step. Because honestly, it's not even asking you to go that far, so you don't need to figure out what the theoretical yield is right now. So if you do this, you should get 0.6295 moles of Cu2S. Okay. Next one is 25 grams of sulfur. What do we do? Molar mass. So it's about 32.066 grams per 1 mole. And then what? Molar ratio. So are we seeing that as kind of a pattern here for all these limiting reactant problems? It's what's the ratio? 1 to 1, right? So 1 mole of sulfur for every 1 mole of Cu2S. And this gives us 0.7796 moles of Cu2S. All right. How do we figure out which one's the limiting reactant?
The one that's less.
The one that makes the least amount of product, right? So in this case, which is the limiting reactant? Copper. Do we all agree on that? I want to make sure everyone understands how to identify the limiting reactant. Perfect. Okay. So we identified the limiting reactant. That's the question. So it says, okay. So it says identify the limiting reactant, that's copper. And it's also asking, I told y'all earlier, it's not asking how much is produced, but it actually is. I didn't read the question. So it says how many grams of product can be produced. So let's just go to this one step further on this one. So we're going to take this. And we use what to get to grams? So 159.092 grams per 1 mole Cu2S. Be about 100.1 grams. How many sig figs do we have? Four sig figs. So that's why it's 100. Because remember, you count after a decimal 80. Yeah. So whenever you have a decimal, these zeros count. Okay. So that's why I put 4 sig figs. Anyone have questions? This is a learning zone, so we love questions here. We don't cloud on you if you have a question. And if
So we'll always find molar ratio with limiting reactants. So like
sorry, I have horrible ears.
Oh no, sorry. You'll always find molar ratio with limiting reactant, like that problem above. Used molar ratio or
so molar ratio is you're always going to use molar ratio if you're going from moles of one thing. So in this case, we went from moles of copper to moles of copper 1 sulfide. So that's how we're going to get to moles of different things. And usually that's when you have a chemical reaction. You want to go from reactants to products in a reaction, right? That's the whole idea of running a chemical reaction. So in order to go from in math, in order to go from the reactants to products, you need to use the molar ratios in the balanced chemical equation. Okay, so that's why we're using them in this problem. Some problems like, let's see, like these problems don't require, there's no reaction happening, so there's no molar ratio to think about, right? It's just asking like how many moles of sodium chloride are in this sample sodium chloride, right? So we're not going to use molar ratio in this case. It's always the problems that have reactions that we use the molar ratio from reactants to products. Does that answer your question? Okay, good question. What is the 159.092? Unless I messed up when I was doing this, that's the molar ratio. That's the molar mass of copper 1 sulfide. That's grams per mole. Yeah.
This is a question more for part A, but so the oxidation is the same as the charge for ionic. How does it differ for like if it was a covalent?
Fish, did you hear that?
So what was your question? Like, how does the charge differ if it's covalent?
No, how does oxidation work if it's a covalent?
Okay,
You're saying if you have something like N2O5 or something?
I'm gonna move on. Y'all can focus over here just because the Zoom people, I don't think can hear them. So I don't want them to be like, what's going on? Okay. So we figured out how much oxidation. Okay, so we figured out how much can be produced. What is that term called? What yield? It's the theoretical yield, right? So if everything was perfect, 80 grams of copper with excess sulfur, since it's excess, since this is the limiting reagent, should produce 100.1 grams of product. Okay, that doesn't always happen though. So now it's asking how many grams of the excess reagent are left over at the end of the reaction. We already said copper is the limiting reagent, which must mean which one is the excess reagent? Sulfur. So care about sulfur. All right. So now we need to, how would y'all go about this problem? Grams of what? So this is a tricky one because you might not know where to start. But this is how much copper or product was produced, right? So if we can figure out how much sulfur was used up from this amount of product, then we should be able to figure out, we should be able to subtract that amount that was used up from the starting amount to figure out the excess amount. And if you don't understand what I'm saying, I'll show you with the math, okay? So 100 grams is how many moles? Well, we already knew what that was here, right? We converted moles to grams. So I'm going to use this number first to save time, which you should do on a test. So sulfur here. So 0.6295 moles of Cu2S. Now this is where you might, if you got here, then you're on the right track. But if you're not sure where to go next, we care about the excess reactant. So let's convert to moles of sulfur. And how do we, I'm going to pick on you at the back again. How do we convert from moles of one thing to moles of the other thing? In this case, it's moles of product to moles of reactant. Molar ratio, right? And where do we get that from?
These
the balanced chemical equation, right? So what's the ratio between these two here? It's 1 to 1, right? Because they don't have any coefficients between in front of them, which means that there's a 1 implied there, right? I'm sorry to pick on you. I just
no, it's fine because
okay.
I understand it.
Yeah. So 1-to-1 ratio. So 1 mole of Cu2S is produced by 1 mole of sulfur. Are we good with that so far? So now let's figure out how many grams of sulfur that was, I guess, how many grams of sulfur was used up from that. So to figure out how many grams of sulfur, what do we use? Molar mass, right? So it's 32.066 grams per 1 mole of sulfur. That cancels those units out, and you should be left with 20.18 grams of sulfur. But is this the amount that is left over, or is this what was used? This is what was used, right? So you can even write, like, this is what I wrote on the key. This is the amount of sulfur that was used. It's used, not used. There we go. Okay. Next, we started off with, going up here, we started off with how many grams of sulfur? What? 25. If we started off with 25, and we used 20.18, this should give you that the leftover amount was 4.1 or 4.814 grams of sulfur is the excess amount. Okay. So that's the answer for that. Show of hands, how many of y'all think you can do that by yourself? That's good. No. Okay. Try this one later by yourself again, without looking at the keys. Okay. I'll post the key literally as soon as I'm done here. All right. You have time for, y'all want to do a net ionic equation, or is that, are those pretty easy? Yes, no, maybe so. Do it. Okay.
Could you please go over it for us?
Yeah, go over this one. Rich,
Yes, please.
It was my problem that I probably made so.
Yeah, it also has your handwriting on the key, so I can't read that. Okay.
All right, let's start off with a molecular equation. Molecular basically means like your elements, what you'd see in like a balanced chemical equation. So let's see, copper 2 chloride. What does that mean in terms of a formula? CuCl2. And then what about silver acetate? What's that as well? So silver, right, is Ag. So let's write that up there. And then acetate, right? If you remember
C2H3.
Yeah, C2H3O2. And it's just like that, right? There's no 2 with it because silver, right, has a +1 charge. And then acetate has a -1 charge. So +1, -1 cancels out. And then what are your products? So do you all know how to predict the products of these types of reactions? Yeah, you basically switch the cation and anion. So here you get Cu, CH3CO2, 2. So copper acetate, that's undusted copper 2 acetate. Then you get silver chloride, AgCl. All right, that just comes from me switching the ions. Did I go too fast for y'all? I see some of y'all kind of confused.
You can like draw the cations in blue and the anions in red and then show them switching if that's not too much work, because that helps me.
I'm too lazy to do that, so I'll highlight. Cations, I'll highlight them in red. And then my anions, highlight that's just blue. Lesson for life, take the shortest path, the path of least resistance. So right, as you can see, the red are my cations and the blue are my anions. So as you can see, the chlorine right here switched places with the silver, or not with the silver, sorry, with the acetate. So the two anions switched, and then right here, these two switched. It's AgCl because silver has a +1 charge, not a +2 charge. So if you do the reverse crisscross, whatever method they call it, then you'll get AgCl and not AgCl2. All right, now are we all on the same page?
Yes.
Right, cool. So now it's time for everybody's favorite topic, not really. It's an absolute pain in the behind, the total ionic equation. Good catch. I was waiting for someone to do that. So, yes, you do need a balance. And why is this not balanced right now?
There's an uneven amount of chlorine.
So how would you balance it?
Put 2 in front of the AgCl as well as the silver acetate.
Like this?
Yes.
All right. Now, is this balanced?
Yes.
Right. Yes. Good catch. So total ionic equation.
What about your states of matter?
Okay. So copper chloride. What state of matter is that? Is that solid, aqueous? It is aqueous because chlorines are normally, y'all will learn this later in the semester, but chlorines are normally soluble, but their exceptions are silver, lead, and yeah, that's all y'all need.
Copper +1.
Oh, yeah, copper +1. But this is copper +2, so that's the exception. That's not an exception. All right, basically this compound is soluble because you have copper 2+ instead of copper 1+. Let me write that out. Chlorine soluble except for Ag. This is 2+, so silver is plus, and then copper is going to be plus. All right, so that is why that's there. Silver acetate, is that soluble or insoluble? Aqueous or solid? It's actually soluble. Acetates are always soluble, even with silver. Like if you have an acetate or a nitrate, those are always soluble.
So then the next one is
So aqueous, and yeah, the next one is indeed soluble because again you have the acetate. And what about the last one, silver chloride? Insoluble because silver is one of your exceptions. So solid right there. All right, now that that's out of the way, total ionic equations. As I've been saying, everybody's pain and behind. So what is the charge on copper? +2. But what is the definition of a total ionic equation? Like first, let's define this. And when they're polar. Or total ionic is when you break up every compound here into its ions. And that's why they call it a net ionic equation, right? Net ionic is like the result of all the canceling out from of the ions from the total ionic. The net ionic just includes the solid and the stuff that make the solid. But the total ionic includes like every single like ion that participated or will participate within the chemical reaction. So, got out of the way. Copper, right? As someone said, has a 2+ charge. Ions by themselves, right, are normally aqueous. So copper 2 plus, that's going to be aqueous. Q. And then what about chlorine? What charge does it have? It has a -1 charge, Cl minus. But how many chlorines do we have? 2 chlorine. So you're going to put a 2 in front of that. You just carry over the same, so the subscripts now become coefficients. You're going to call out equation. So right, you have this as in fact an aqueous. And then right, silver. What charge is silver? +1. How many do we have? So 2 Ag plus. That's also aqueous. And then you have 2 C2H3O2 minus ions. That's also aqueous. And then you have copper again, 2 plus, nice and aqueous. Then you acetate again, C2H3O2. But wait, how many acetates do we have? 2 acetates. So just put a 2 in front of that there. That's also aqueous. I'll just put parentheses on this to make it more clearer. All right. Now, silver chloride. We said that was insoluble, right? So if something is insoluble, can it break up into its ions? So how would we write this in the total ionic equation? Straight up, exactly. AgCl, it's solid. It would be 2 AgCl. See, that's why it's important. You always got to think about your coefficients. In fact, sometimes in big bold letters, Dr. Armand is nice to you, and he will write the words unbalanced in this exact font. So it's nice, or because he knows there are people like me who don't read coefficients. All right. Now, do you all see why that was a total pain in the behind? I had to write out every single ion and like do that, all that. All right, so that's total ionic. Now time for the net ionic. What do we do for the net ionic?
The stuff that's the same.
There's a name for the stuff that's the same. Spectator ions, exactly. So cross out, spec. I'm just going to abbreviate that, spec ions. So what are my spectator ions? This reaction.
That aren't involved in the AgCl.
So which ions are those? This reaction.
Copper and acetate.
Copper and acetate. So bye-bye, goodbye, good riddance, see you later. Those are all my spectator ions that I've crossed out. So right now our net ionic equation is the stuff we didn't cross out. It's the solid and the stuff we used to make the solid. So what is the net ionic?
2Cl negative plus 2 Ag positive.
2 Ag positive.
Yields.
Yes. Plus 2 Cl minus aqueous makes 2 AgCl. Solid. But we're done here, right? That's it. It's final answer.
Probably not.
Yeah. So what you're gonna go ahead and do is you can actually reduce all of these to their lowest terms. Fancy word for that is divide everything by 2. Because 2, you know how in like equivalent, like, okay, 2/4, right, is the same thing as 1/2. So like you get that there by dividing by 2. It's the same thing here, like 2 Ags, 2 Cls, 2 AgCl. That's the same thing as this. Ag plus Cl minus makes AgCl. So this is an aqueous again, that's an aqueous, this is solid. So you got to reduce everything down to its lowest terms. That's what I mean by that. Right. Any questions about any of this problem?
Yeah. The spectator is what doesn't form a solid, right?
Yeah, spectator is anything that doesn't form a solid.
It's what stays the same on both the left and the right side of the left and the right side of the You can just kind of think of them like not participating in the reaction, which is why they're spectators,
yeah.
Right? Chlorine, yeah, chlorine's diatomic, but
But
we're not
that's
talking.
chlorine gas. This is aqueous.
Yeah, exactly.
Right. Any other burning questions or desires? Or are y'all just gonna go like cry in a corner for 2 hours until the exam?
Wait, what?
I was just asking if there are any questions or if y'all are gonna go cry in a corner for the exam. I know if that was me, I would have cried in a corner. Yeah.
I was stressed for this exam. It was online, it was proctored on Proctorio.
Yeah. You had to do like a whole 360 room scan. It was not it.
Yeah.
All right. Somebody said we want to do a density problem. You have any here?
Maybe,
Density.
maybe not. Yes.
On a scale of 1 to 10, like how hard would you say it is?
Like
1 being like the easiest exam I've ever took, 10 being like I cried in a corner for like 2 weeks.
Yeah,
I'd say like 4 or 5.
Okay, now
in
compare it
comparison to like
to the other tests.
In comparison to the other
this-
tests, I'm giving that like a 7.
wait, what?
Yeah.
it was hard. It's
It's
harder.
harder than the other test.
Sorry, easy. Like
By like, so in comparison to the other test, is it like a
The other
one?
test you're gonna have, yes.
compared to the other tests,
This is like the easiest exam of the whole semester.
yeah. But
It's all downhill from here.
yeah, exam 2 is going to be the hardest. And yeah,
It was actually uphill for a lot of the students that came to our sessions last semester. They started with like a 50 on this exam. They got like 100 on the last. So
but some of them even like 110, 115.
yeah. Some of them only missed 2 questions on the ACS final.
Hey, that's better than mine.
But they were in the same boat as y'all were. They were like, oh, I hate chemistry. I'm bad at it. I'm gonna fail this class.
One of them literally consistently said, I'm going to drop this class.
Yes.
So if we do bomb this test, like, we can just be very nervous.
Not really. If you just bomb, like, if you bomb this test, you can like, there's always opportunities to bounce back on other tests.
Because you get 1 dropped exam. So if you have to drop this one, then you'll work harder for the next one and you'll get the grade you want on the next one. So I would have planned.
Star scooters, yeah, 4 or 5 difficulty, yeah, but in comparison to other exams, like 2 or 3.
Yeah.
Well, it's just like the week of the exam.
No, we do this like every week.
It's just the first week there was like, we didn't do it because
I know that the stars tutor, is it like around the same time like this or?
You have to go to 1 star student in particular, Almer Nacha, great guy.
yeah, he's one of our like best friends, but I think our sessions are better than his.
Yeah.
Just kidding, I'm just kidding.
Only after the stars tutor, like the schedule came out and I have a class like every single day. Well,
How does this schedule work for you?
it's,
Interesting.
I work, so.
You
like,
stop the recording now, Rich.
There was 1 request for a density. I was just trying to hold up.
You try to make one up.
All right, let's
do a made up element name.
okay, a new element name.
So look at your test guys. See y'all later.
Thank you.
You're welcome.
New element name
Just anything.
backpackium. Let's say BP.
Has a mass of 92.4 grams per milliliter, or has a density of 92. My bad.
Density of 92.4 grams per milliliter.
Can y'all read that?
That's even worse handwriting.
Really nice.
Yeah.
Nice. You keep roasting about my handwriting. All right. Anyway,
I can't roast it if you like.
please don't. I want to keep my ego inflated. 92.4 grams per milliliter. What?
What is the mass of a sample of backpackium that is 4,372 milliliters or liters?
That's
I'm just making up numbers. This is
4,000.
literally how I made all the questions on this thing. I just was sitting there, okay, random number.
All right, my Zoom people, my party people, how do you guys go about solving this problem? What will be your first step?
What about our in-house people?
Everybody AFK.
Not the party people. Like,
Yeah.
party people.
So somebody said they write the formula. So I would also write the formula. So density equals mass over volume. And then somebody went another step further, multiply the given volume by the density. Can we multiply the given volume straight up, room people?
No.
Divided by 1,000, exactly. So 4,372 by 1,000, you get 4.372 years. So your density, right, that's going to be 92.4
Look at your density units.
grams per milliliter. However, you can convert that to liters. 92.4 grams per milliliter. Using our dimensional analysis, analyzability,
Or you could have just used the, you didn't
we
have.
know that 1,000 milliliters are in a liter. I'm doing it the more complicated way. If y'all can do it this way, you can do it any way.
What?
I think you could have just,
Okay, yeah, let's just scrap that.
everything was perfect. The units were matching up, so all you had to do.
Wait, no.
Yeah, all you had to do was multiply them.
All right, so 92.4 grams per milliliter. And then mass. We'll call that X because we don't know what that is. I'm still trying to find my X. Don't ask why. Okay, I make jokes sometimes. Okay, 4,372 milliliters. So 4,372 milliliters. This is grams over milliliters, and then you multiply by milliliters, so it all cancels out and you get grams. All right, now if we use our fancy calculator device, this is my fancy calculator device, but we'll. Well, I know how to turn on. There we go. 92.4 times 4,372. That's not 2. 92.4 times 4,372. You solve that out, you get an answer of 403,972.8 grams of backpacking. All right, so to recap what I sort of did, first you write out the formula, density equals mass times volume, and then you figure out what you have in the problem and what you're trying to solve for. In this case, we had both our density and our volume, and we're trying to solve for mass. So in that case, we solve out an expression like this to make sure our units match up. So grams per milliliter and milliliters in this case, right? So they both match up. So what we try to do then is get X by itself. So multiply both sides by 4,372. And then we get that X is equal to 4,372 times 92.4. If we solve that out, we get 403,972.8 grams. So that's how I arrived at that answer. Do you have any questions about that? Person who asked for density problems, you sort of feel better about them now?
About significant figures.
Significant figures. So yeah, well.
This guy Rich never does sig figs.
See, I'm in organic. We don't do sig figs in there. Well, we don't do anything with numbers in there, but minus degrees of unsaturation. Okay, so anyways, there's 3 sig figs in this number, and there's 4 in this number. So how many sig figs should our answer be? 3. So doing our scientific notation stuff, we get 1, 2, move that over. 1, 2, 3, 4, 5. So this is 4.04, 3 sig figs times 10 to the 5th grams of backpacking. This is the actual number. This is the number with the sig figs. And if you get this on a test, what number should you enter into the iClicker? The number with the sig figs, this one. Do not enter your long decimal answer, you will get it wrong.
Y'all said the other day that it would be right, that there'd be a range.
I did say there would be a range, but I didn't say anything about
Sig
the
figs,
right
though.
sig figs.
You have like the right amount of sig figs, but it's off by like 1 in the 10th place or 100th place. Maybe you'll get the right answer, but if you have 10 decimal points, that's like, oh, well, they don't know about sig figs.
Nobody's trying to read 10 decimal points, so yeah.
There's a range of answers, yes, but make sure your sig figs are right.
All right, any other questions? Can you just multiply them? You ask if I just multiply them? Yeah, can you just multiply them? Yeah, that's basically what I did. I just multiplied them. I'm teaching here, so I'm trying to like go step by step.
Yeah, if you weren't here yesterday, right?
Yeah, yesterday.
The video was just posted a little while ago of what we went over, which was the first half of that worksheet that we did in the first part of this session. Okay. So yeah, if you're in our bots class, we'll see you later while we'll be proctoring for you.
And y'all are now free to go cry in a corner. Have a great day.